Real-time novel view synthesis for volume rendering using a piecewise analytic representation. Our approach represents the image produced by volume rendering from one view, right, so that it can be seen from other views, left. Note how both the surface and the complex interior structures show correct depth parallax. The typical image-based rendering artifacts are also present for volumes. A reference is shown on the right for comparison. Here we show the challenges of novel view synthesis for volumes for an extremely simplified volume. Previous approaches have converted volume rendering into multiple discrete surface layers. Here we see the approaches of Zellmann and Müller. Our solution reverse engineers the volume rendering solution and fits a piecewise representation to it. This results in the correct image from the original view, but also in correct volumetric novel views. The complex three-dimensional surfaces in the interior of the scanned walnut specimen get preserved. While the top layer is fully preserved, interior layers get increasingly blurry under novel views. Again, a reference is seen on the right. Again, surfaces lying under other surfaces are seen for this specimen. Repeating patterns can cause moire effects typical for surface-based image-based rendering. This synthetic dataset shows large homogeneous regions that are a stress test for every novel view synthesis. While colors appear to be correct, layering can become visible. Complex shading, such as multiple scattering in clouds, is supported by our approach. A typical application of volumetric novel view synthesis is remote rendering in games. Here we see another cloud where our approach is used to compensate latency of more than 150 milliseconds, the typical latency of a modern internet connection. The cloud is rendered on a server while the simple plane is rendered on a client. Failing to compensate for latency, seen now, would introduce lag between user motion and images, leading to cybersickness. Depth of field can be costly to compute for volumetric scenes. Here we use our technique to simulate the views of individual lens samples. Finally, another complex specimen with detailed volumetric structures seen from novel views. Our piecewise analytic representation reproduces in real time the transparent floating structures that are part of the dataset, the more opaque parts, and the subtle layers of transparency around the teeth. Thank you.